Ladies and gentlemen, welcome to this ETIPWind Event, Getting Fit for 55 and Set for 2020, or Electrifying Europe with Wind Energy. As you all know, Europe has pledged climate neutrality by 2050 and a reduction of 55% net emissions by 2030. That means that 3/4 of the energy system will need to be electrified, directly or indirectly. Continued cost reduction of wind energy actually puts this power technology at the core of the system, accounting for more than half of the electricity we will consume in 2050. And this is economically feasible. From our calculations, we see that the cost of it will not be higher as share of GDP in 2050 as it would have been in 2015. Not to mention all the benefits that we get out of being fully sustainable, such as the quality of the air we breathe. But transforming ourselves and get there will really need a genuine growth strategy. Right, where we will need to prioritize the technologies we are investing in. We need to prioritize the project and the infrastructure we are developing, and particularly also the business models among the stakeholders to drive ourselves as quick as possible into the direction of being carbon neutral. My name is Adrian Dimbush, and I'm the chairman of the Executive Committee of ETIPWind, the European Technology and Innovation Platform for Wind, and I'm delighted to be joined here by a distinguished panel to discuss how we take this forward. I will start with a few questions for the panel, but all of you out there in the audience, please prepare your questions. We will take it at the end of the sessions, and let's make it as interactive as possible. So with me here today, we have João Galamba, Secretary of State for Energy in Portugal. We have Rosalinde Vardefleis, Director Clean Planet, European Commission, DG RTD. We have Boz Polkort, Senior Vice President for Innovation and Concepts at Vestas. We have Elizabeth Brinton, Executive Vice President, Renewables and Energy Solutions at Shell. Rasmus Erbo, Senior Vice President, Head of Continental Europe Offshore at Ørsted, and Alexandra Beck-Gjørv, CEO of SINTEF, the Research Institute in Norway. So let's go back and look at certain aspects that we have highlighted in this report here, and all of you should have access to it right now in the resources page on the website. First questions to you, Bo. Right? For such a strategy, we need to unlock a massive supply of competitive wind energy. Can the technology actually deliver? And what do we need in terms of policies to make that happen?
Thank you, Adrian. I think yes, of course we can deliver. Is the technologies there that we need? No. It needs funding, it needs research and development. But I think we have proven the track record is such a way that we have demonstrated our ability to come down in cost and to deliver the scale that has been needed. It takes, as I say, funding to do that, right? And we need investments to drive the technologies. We need the investment to scale this massive inflow of wind energy that we want to contribute with. So it doesn't come without funding, without research. But I think we have shown, the industry have shown our ability to deliver what is needed. In the report, I think it's shown that on onshore, we have doubled the scale in 10 years of turbines. We have done the same for offshore. And if you look to the numbers for the big turbines, we have even more than done that. Right? So actually, we have done what is needed to come down in cost of energy, and now we are ready for the next giant leap and for this major upscaling. But again, it needs money to drive that, and we want to do the investment. We want to do the innovation, the research. We want to collaborate with universities and partners, and we need that. We need the funding to do that, and to provide the funding, we also need the certainty. We cannot live in an environment where the uncertainty of whether we're able to build, or customers are able to build, outbuild the offshore and the onshore, and also the floating. So certainty around the economics, certainty around the permitting is essential for us to be able and to take a part of the risk of upscaling these technologies. They're not all there, but I believe that we can do it. We have shown that we can do it, and we have the ability. We don't lack ideas and innovations. We will provide what's needed to drive the grid future, or the resilience of the grid when the fossil fuel plants are disappearing or decommissioned. We believe in total sustainability, and we drive the innovation and also technologies in that area. So I think we are on the right path. We can deliver, but it needs certainty, and it needs a way forward from the policymakers. And coming to that, we need more secure on permitting the consenting side. Back in the 60s and 70s, we deployed fossil fuel plants also in the neighborhood of Vestas headquarters. There was no argument. We needed the growth. Now we simply need to change, because we need the climate to take over, and we need to be able to impact the environment and make sure that it's done in a good way. But we can do it, I'm sure.
Thank you very much, Bo. Elizabeth, coming to you. Moving to net zero requires system-wide thinking, right? What will be the key drivers for electrification, and how do we stimulate the demand for it and to consume renewable energy?
Thank you, Adrian. It's a really important question. So systems change is really important to have the policy alignment, and it actually picks up on something that Bo was just saying, so that we have forward line of sight of certainty looking at the energy system as a whole, so that you create actually incentives to drive the right type of energy that's greener and cleaner, and have very clear carbon pricing, very clear targets that enable, whether it's expanded renewable energy targets, that really expand that direction and pathway. So you have certainty, because again, these large scale projects, this type of scale projects that we need to move the needle, they're expensive and they take time to build. So anything that we can do around permitting certainty, clear renewable portfolio standards, other mechanisms that really make sure that that pathway is clear is really important. So we're very encouraged, for example, by the European Commission's determination to work towards an integrated energy system, because this way we can also drive better price affordability for communities and society by reusing infrastructure. So for example, for the energy systems as a whole, green hydrogen is really important because it can become a storage mechanism for the electrical grid. PEM electrolyzers, for example, are really great. We're building one in Rhineland, for example, right now. It's going to go live very shortly. And you can use it for grid stabilization. It's also an energy vector that we can then use to decarbonize industrial sectors or into transport. So it's making these linkages through the system, and then where governments can come in and say, okay, it's okay. We can actually look at where we can have injection into pipelines and put in more hydrogen and reuse some of that industrial infrastructure. All of that does is it supports an affordable transition. It also supports society by keeping costs low. The other thing I want to cover is also market reform. This is another thing that's really, really important, is how we can get certainty on pricing so that you can, with market reform, you're actually enabling mechanisms, whether they be capacity mechanisms, ancillary services mechanisms, where you can actually begin to use your infrastructure for different things. So you can, like I mentioned, the electrolyzer can help with grid stabilization. We have in our mobility business, that's part of my business, we want to drive the creation of green electrons through our wind, and then also be able to support green hydrogen. But then also we have our company called New Motion. And so if you're an electric vehicle driver, whether you're a consumer or a big commercial fleet, you want to know that that car is powered by green electricity. So then in turn, how do we use all of those charge points, where we have charge point as a service? We're able to help our local grid operators do local frequency and voltage regulation at the nodal level, so that we're actually addressing system stability and resiliency at the same time. So it's really connecting all of the dots from a policy perspective, getting out of silos from a policy or regulatory perspective, and then driving return through certainty, as well as the ability to value stack across different use cases for our customers.
Fantastic. Thank you very much, Elizabeth. Rasmus, over to you. The EU needs to plan for the infrastructure to be the backbone of this net zero energy system. And considering the long lead times that we have really here, what are the key choices that we need to make today?
Thank you, Adrian, and thank you very much for the question and also the invitation. Just before I come to your question, I would of course like to congratulate ETIPWind and ETIPWind Europe on a very good report. It will not be easy to meet Europe's climate and energy targets, but in Ørsted we believe it is 100% possible. And this report points exactly to some of the key challenges that needs to be addressed. On your question, I would like to mention 3 areas, also a little bit referring to some of your points, Elizabeth. 3 areas in which improvements are needed to ensure a future-proof energy grid system in Europe. First of all, on the point on a forward line of sight. Regulation needs to free up some of the ties that are currently put on TSOs when they invest in electricity transmission grids. And regulation needs to allow for so-called anticipatory investments. So TSOs are not restricted to invest only for short-term needs, but are in fact allowed to also make investments based on expected deployment of renewables 30, 40 years into the future. I think a very good example of such anticipatory investment is the establishment of the energy islands in Denmark, where, for instance, in the North Sea, we have planned a 3 gigawatt offshore wind tender, but the infrastructure for 10 gigawatts spanning across several neighboring countries is already envisioned as part of the plan. And I think this is a pretty good example of I think, what is needed across Europe. And as a side comment, it should of course also be mentioned that the same forward-looking approach should also be allowed for DSOs who will need to handle an increasing share of electric vehicles and heating appliances. My second point is that we need to ensure a constructive and partnering-driven dialogue between TSOs, renewable energy developers like us, and the political level. To properly map out infrastructure needs and not least to ensure the political commitment to the increasing build-out. And then finally, my third point is that the regulatory framework remains a barrier for offshore hybrid solutions in terms of the grid build-out. So therefore, we encourage the European Commission to present its planned amendment to the relevant European market rules to facilitate offshore hybrids as early in 2022 as possible. And maybe just to elaborate for 1 minute on the last point, and then I will pause. The so-called hybrid projects, so where wind farms are combined with an interconnector, thereby connecting the offshore wind farm to 2 or more markets instead of just 1. This will be crucial to allow larger scale deployment of offshore wind across Europe. But the current European market framework makes the business case for such projects very, very difficult. And this is understandable, as offshore hybrids were barely talked about when the clean energy package was adopted. But since the adaptation, several hybrid projects have been announced, like I just talked about. So while the consequences of such regulatory change obviously need to be very well analyzed, there is also an element of urgency, as we could see a delay of offshore hybrid tenders if the regulatory framework is not in place. I would like to leave it at that for now and would be very happy to elaborate further in the Q&A session.
Thank you, Rasmus. Hopefully we have the options to come back there. Now, reflecting on what was just said related to policies, right, and the regulatory environment that needs to evolve there, Mr. Galamba, what will Portugal be pushing as part of the Fit for 55 package? You are muted, sorry.
Yes, let me start by thanking ETIPWind for the invitation to participate in this roundtable and share some of the Portuguese ambitions when it comes to the energy transition. Currently, we are, for our Fit for 55 package, we have a very ambitious national and energy and climate plan, and we will reinforce it with, we are giving a higher priority to wind than we did 2 years ago. 2 years ago, the main technology that was lacking in Portugal was solar photovoltaic. Although Portugal has a huge potential in this, we were early movers in wind and late movers in solar. And now, in the last year, what we came to realize was that offshore wind, which was a technology that we were pushing further towards the end of the decade, we are now pushing it earlier. So complementing what we're doing now with the solar auction, we were going to move ahead with them. We are now licensing the projects that won the first and the second auction. We are currently in the licensing stage with some difficulties, but we are moving ahead. And we are moving up our plans for offshore wind. Why? Because we have more ambitious goals. So we believe that this pushing forward offshore is the right move to align Portugal with the more ambitious goals for proposed to the Portuguese government project in offshore wind. Just to have, for you to have an idea, what Portugal with 24 megawatts. It was a pilot project that started 10 years ago, was installed 2 years ago, and it's now fully operational. And we have, in the early licensing stages, a 6 gigawatts offshore wind project in Portugal, in the center of Portugal, and 2 more, smaller but quite large, in the north of Portugal. So because of this, we are updating our plans, mainly regarding offshore wind, and what was planned to exist in Portugal closer to the end of the decade, we now believe that it's going to be much earlier. So we are updating our plans for renewable capacity installation, and the biggest change is a higher priority than we envisioned 1.5 years ago regarding offshore wind.
That's very encouraging to hear, right? We all know that the coast of Portugals are not suitable for, let's say, all suitable for fixed installations of wind turbines, and it's more going in the direction of floating wind. Could you elaborate what will be the share and how do you see floating wind evolving in Portugal within your plans?
Sorry, can you repeat the question? I didn't quite hear you.
That's I was referring to the floating wind technology, right? Because the coast of Portugal and the seas of Portugal are not suited only for fixed structures, but also suited for floating wind and actually requiring floating wind technologies. Could you elaborate how do you see floating wind in your plans?
I will say even more than what you just did. Fixed offshore wind is not suitable for Portugal. So it's not even a matter of combining fixed offshore wind with floating. It's the only suitable technology for the Portuguese shores is floating offshore. So we currently have many companies in Portugal developing and improving floating technology, and we believe we have the engineering capacities and the resource availability for offshore, for floating offshore wind to be a reality around in a very large, starting in 2025-26. The license these projects, especially due to the size and to the technical difficulties, are complex. So when I mentioned that we already have a 6 gigawatt project in the early licensing stage, that project plans to start producing in 2025-26, ETIPWind, a project that is now entering its early licensing stages, believes that it will take 3 to 4 years to start producing. But we are very optimistic regarding the outlook and the interest that we're having for many promoters in Portugal. And we believe that a large-scale offshore wind production will be a reality within this decade, not in the first half probably, but surely in the second half and early stages of the second half of the decade.
Thank you very much. That's even more encouraging that we are not only looking to get the right capacity of offshore wind, but also getting it with the right technology whenever it's suitable, that being in this particular case, floating offshore wind. Talking about technologies, Alexandra, what it is now, where EU basically should put its R&D money specifically? Could you elaborate a few areas?
Well, I don't think I want to point to an individual area, because offshore wind is a truly multidisciplinary endeavor. It's a capital intensive and long-term business that needs to be progressed and needs to avail itself of all new technology options. And I think European collaboration on research and innovation is key to unlock this tremendous opportunity to realize the Green Deal, net zero, but also do no harm. Because I think while it is tremendous growth opportunities, and I want to thank you for this report, which shows that offshore wind can really, really make a big difference. Of course, with such a big development, there's also side effects and impacts on other industries. So I think one of the areas to be researched is the sustainability coexistence with nature and with other industries, such as the fisheries. Now, obviously, both fixed and floating structures need to avail itself of all the improvements within digitalisation, the substructures, the marine operations, logistics, electrical infrastructure and systems integration are all highlighted in your report. And those are fairly mature technologies that need to be, well, I wouldn't say mature, but it's collaborative research with our industrial partners. We just collected 50 partners in a research center in Norway to realize this now. But there are also some more fundamental research fields, including the understanding of atmospheric and wind power plant flow physics, interaction between the aero, structural, electrical, and offshore wind hydrodynamics of enlarged wind power plants, and the system science for integration into the future electricity grid. And I think especially the last one, the integration in the future grid, is not only a scientific endeavor, where it's an area where you need to see market operations and regulations together with the technology development. So all this needs to be looked at in a truly multidisciplinary fashion.
Thank you very much, Alexandra. Now, with wind being such an important part of our net zero energy system in 2050, Rosalinde, where the Commission should put the priorities for wind when it comes to research and innovation?
Thank you very much, Adrian, and let me also start by thanking the ETIP for the kind invitation. It's really a pleasure to be here with such an interesting and distinguished panel. So let me start by saying in the first element of response to your question that we are very, very proud that we have with Horizon Europe the biggest framework program public funding in the world now. We have 95.5 billion euros for the next 7 years to invest in research and innovation at European level. And I think that also shows the importance that Europe attaches to research and innovation. And of course, we all agree that research and innovation plays a crucial role on the path to 55 and beyond. Now, for the priorities that we are setting in Horizon Europe, one of the novelties of this framework program compared to its predecessors is that it is very impact focused and really focused and determined to deliver on the policy objectives. So not only the objectives that we've set ourselves in the European Green Deal, the 55% reduction target, but also the objectives in the related European Green Deal strategies, such as the offshore offshore renewable energy strategy, where we have set very ambitious targets to increase the offshore wind capacity to 300 gigawatts by 2050. Another novelty of the program is that we now have this cross-sectoral approach. And some of the other panelists already mentioned the importance of this cross-sectoral approach. So we have the famous Cluster 5, which is dealing with energy, climate, and mobility into an integrated cross-sectoral way. And we will have 15 billion euros for the next 7 years for this Cluster 5. So within the Cluster 5, we will, of course, also invest in research and innovation activities related to wind. And I fully agree with some of the previous speakers that underlined the sense of urgency. I really believe that if we want to meet our climate ambitions, that we need to invest in the right priorities in this moment in time. And basically, I don't want to sound too dramatic, but I really think that this is kind of like a last chance to get it right. And the priorities that we identified in the Cluster 5, by the way, we will publish the work program in the coming weeks. This will then be open, and the first calls will be launched towards the 22nd of June already. But I could identify 4 key areas on research and innovation actions. The first is, of course, on the technology, and there we need to focus much more on the efficiency and the cost effectiveness, both at the turbine and systems level. The second one is to use better the natural resources and the currently untapped or underdeveloped geographical basins, for instance, in the Atlantic or the Mediterranean Sea. And the third one was actually already mentioned by Alexandra, and this is, of course, very, very important to us, and this is to really look at sustainability. So to look at the environmental impacts, where we also will be paying a lot of attention to circularity, recycling, substitution of raw materials. And the last one is the society. And I think that is a very important one. I think we should not forget that we need the societal engagement, also societal acceptance, and upskilling, reskilling, and training. So in a nutshell, these are the 4 key priority areas that we'll be looking at in the first work program on Cluster 5. Thank you.
Thank you very much, Rosalinde. And I think there are very interesting questions coming in here. Please provide them more. I will start taking some of them to our panel here. And there is a very interesting one for you, Bo, on technology. But before we go there, let's look a little bit of concrete examples of plan. Elizabeth, Shell, right, has set a net zero target emissions on energy business by 2050. How do you plan to reach that target? And more specifically, what role will offshore wind play in that, particularly here in Europe?
Thank you very much. It's a great question. And as the leader of the business, to me, it's very practical. The green direction of my business is very clear. And, 2050 is a long time from now, but today is what I really care about, is on that trajectory. So I'm really focused very practically on competing for and building a very, very big scale business, including offshore wind, fixed bottom and floating, including green hydrogen, as I mentioned before, also including electrification of vehicles, and a whole different host of really important technologies, including onshore renewables, solar, in this case, hybrid projects. And I mean by hybrid there in terms of mixing different types of technologies, such as battery storage with solar, these types of projects. So it's taking a very practical, we're looking at very aggressive targets each year on an annual basis for the business. And that then sets us on a very clear pathway to 2050. And I think what's exciting about where we are now in this discussion, in this panel, and also where policy and society is that those of us who've been in the renewable business, and I've been in for decades, is that suddenly now this is mainstream. And so now we can have a conversation about actually what some of us have been working on for a long, long time. And that's really, really exciting. And so this is a key decade. And so really, this is about very practical targets. So rather than talk about 2050, which is essential for the policy certainty we were discussing earlier, what's really important as a business leader in this space is thinking about making sure we have the practical support, whether they're renewable portfolio standards, whether it's revenue support flexibility like CFD, contracts for difference mechanisms, things that really make the projects near term, because these are all long-term, big-scale projects, and we need the scale to make the difference in Europe. So how do we really make sure that we're really, really practical in the here and now, right today, making sure that we're supporting governments, society, businesses, and balancing that supply and demand? That's another important point, is making sure that we're thinking about, and this is what's great about the National Recovery and Resilience Plans, thinking about RED II delegations for hydrogen, thinking about industrial electrification, which goes back to the system discussion we were having earlier, making sure that we're putting together that ecosystem that supports commercial developers like myself, having a very practical business that we can really grow. We're leaning in, we're ready, technology is there, as Bevo was talking about. See, this is my lead into your question. And really being able to make sure that we can go forth and build, because we're already building, we're already building wind farms, we're building hydrogen electrolyzers, we're doing these things. We've got charge points, we've got electric batteries. We're orchestrating the largest battery in Europe right now out of the UK. So we've got these material positions, but it's a matter of how do we make sure that we keep the doors open of policy so that we accelerate the ability to scale. And so in a nutshell, in summary, we're focused not on, 2050 is the North Star, but in reality, it's all about today and just being very, very practical. And it's so exciting to actually see this mainstream now today. It's a really fun business to be in.
Indeed, it's a very dynamic and fun business to be in, Elizabeth. Now, Bo, come back to you, right? You, in your earlier intervention, you started directly with the funding and investments. But, you know, wind power, it's quite a mature onshore technology. Could you say where we need more funding and investments right now and what the problems to solve are?
Yeah, I think I can do that. So on the technology side, we have proven that the cost of energy have come down by scaling the size of the turbines in general, higher capacity factors. But that scaling comes with a cost, right? To increase the size of a turbine deems new technologies. And also when we look to the sustainability, the material side, how do we make sure that we can develop blades with the industry that can be decommissioned, that we don't have to use like landfill. So the development into new materials around the circularity, the sheer size of these new turbines, how do we get them to site? What kind of new solutions do we have to develop to transport them to site, to install them, and to maintain them? Right? This will not be the technologies that was available 10 years ago. Right? We will need to develop technologies that will push for the 10 years leap. Then looking to all the grid side, when the fossil fuel plants are being decommissioned, right? Turbines and wind need to play an important factor in maintaining the grid. The turbines need to be developed so they can do that. It deems new capabilities, links also to the digital side of all the interconnection, connection to storage, how you integrate also to the power to X, how do you develop this ecosystem and make it cost effective and make it seamless. I think that takes a different story and a different investment. We still need to develop new turbine types and new versions of that, but we have to develop so much more, right, to be the backbone of the energy system for the future. We need to link up to storage, link up to power to X, and all this comes additional. And I think we embrace that new technology and that new ambition, but it doesn't come for free.
Thank you, Bo. Thank you. And Rasmus, you mentioned hybrid projects in your statement, and immediately we've got the questions on that, right? They typically connect exclusive economic zones, right? And how do we solve or resolve the different rules and regulations that we have at different countries, right, to get that enabled, you know, the utilization of hybrid projects there? Any comments from your side?
Thank you. Good question, and also a bit of a tricky question, actually, and with a relatively complex answer if you go all the way. But I think if we take a step back, the way I would look at it first is just to appreciate the fact that you can say the business case for hybrid solutions from a societal perspective is incredibly attractive. So the combination of an offshore wind farm to an interconnector that might be there anyway to two markets, etc. Just all of that brings a attractive business case from a societal perspective. Therefore, the question is, how do you then best sort of deal with that between the developers, between the TSOs, and between the different member states? So it's a positive challenge, the way I would look at it. And I think that's my point number one. My point number two would be that this is exactly where we need the European Commission, where we need initiatives like this, because this obviously requires a very significant element of, you can say, partnership-driven dialogue between member states, developers, and also with the TSOs. More specifically, and that's my last point, the things that needs to be looked into is, of course, how do you then allocate the different elements of the business case between the parties involved. A good example is congestion rents. How do you deal with that in the context of a hybrid solution? Another good example, not specifically related to the business case, but to the coordination needed, is maritime spatial planning. You need to look at that, obviously, at European level. So those are some of the things, Adrian, that comes to mind on a question like that, and also why I said before that the urgency on the regulatory side is something that we really believe is the case. Thank you.
Thank you, Rasmus. Now going back to the plans and the intentions of the European Commission, Rosalinde, the EU state aid rules are being revisited this year and must support innovation. Will DG RTD push for expanded support for installations, such as the cases of Germany and France, where we see that we are not just, innovating or pushing or putting money in the early innovations, but also help the industry pilot, help the industry commercialize solutions to get us faster, right, into the implementation phase.
Yeah, thank you, Adrian, and a very important question. I mean, I think there are various elements here. I think the first thing is, of course, I was starting my intervention by saying how proud I am of the big priority that the European Union is giving to investing in research and innovation. But of course, if you look in the European Union as a whole, of course, what we are investing from the European Commission side is a drop in the ocean. And that's why it's so important that we work very closely together with the member states and the private sector. In particular, with the member states, we will be launching a co-fund, which we call the Clean Energy Transition. This will be a very important vehicle to work together with the member states to get to this energy transition and to accelerate it. And it will also help to meet the targets that we put in the set plan, for example, on the wind technology as well. So I think cooperation with member states is extremely important. This was also highlighted in the recently revised industrial strategy that the Commission published a few weeks ago. And you're probably very familiar that the Commission is working with industry in these alliances. And for instance, we have an alliance also on hydrogen, and there this is a very good opportunity to then identify, which technologies and which investments that member states could be usefully making, for example, through important projects of common European interest. So I think it is indeed very, very important that the regulatory framework is fit for 55. And as you know, we have a legislative package coming up mid-July, where the European Commission will be proposing adaptations to existing pieces of legislation, for example, the Renewable Energy Directive or the Energy Efficiency Directive, Energy Taxation Directive. So we're very excited about it, and my colleagues are working very hard to get this package out mid-July. And of course, the state aid rules should also be fit for 55. And of course, I cannot prejudge the outcome of the revision there, but I've clearly heard the message behind the question, so I will definitely take this with me. Thank you.
Thank you very much, Rosalinda. We were looking forward to see how that will shape up. Next one we have here, one specific for you, Elisabeth. Do you think that standardization of floating wind supply chain is possible? And do you think it will cut the cost significantly? And how will it do it, if at all?
Thank you. It's an interesting question because floating is really emerging and it is an opportunity globally. I think there's tremendous opportunity for floating wind. We're very, very excited about it. We purchased the pioneering floating offshore wind company, ALFI, and we're up in project. We have live projects around the world now, a few, and we're really excited. So I appreciate this question. It's actually a challenge on two areas. So there's the technology and the supply chain on one, which as you get more projects, by definition, the cost will begin to come down and you'll begin to build supply chain efficiency. But there's actually, it kind of goes back to, Rasmus, something you talked about earlier, which is really thinking about efficiency and standardization on the project front. So how do we take newer types of projects in the floating area and then be able to have permitting, streamlining? How do we clearly identify regions that are going to be perfect for floating? For example, we've heard about Portugal, things so that there's clear, there's line of sight, and then setting anticipatory processes in order to really streamline the development, which then in turn will create this virtuous pull through on the supply chain side. Again, if you have that line of sight, then technology manufacturers, OEMs, all the different members of a supply chain can say, okay, here we see the market coming, we have line of sight on timing. And so, then that becomes very, very practical. So similar to my comments earlier, to me, when you get into standardization, it's also something, Alexandra, you mentioned, these are very multidisciplinary projects. So it's thinking through, where do we cut across our silos, and where do we make sure that we can support standardization around interconnection, for example? Where can we really support new types of technologies or even new methods of manufacturing, such as 3D printing, things like that are going to bring costs down across different form factors of the technology that may be used in a particular project. And then thinking of the project economics itself, how can we get standardization across a certain region or basin that's going to accelerate and de-risk the project? Because one of the things we have as a challenge in floating still is a lot of the financial investors and banks still are like, whoa, floating's a little bit too risky. They don't think of the projects as bankable. The infrastructure investors aren't keen on it yet. They're very excited about fixed bottom because they're familiar with it. When just a few years ago, that was the risky technology category. So it's about how do we de-risk the technology and how do we bring our friends in the financial space along with it, so they see and realize that actually floating is not as risky. It's very practical and it's essential, which goes back to that importance of policy certainty. So a lot to unpack there in my answer, but it's not just about the pure product supply chain as a whole. It's actually thinking about it from a financial and a project perspective. And that's where together you have those different levers and then you can lower your cost. Thank you.
Yeah, very good, very good. Then maybe Alexandra, on just what Elisabeth was saying, right? Where is research coming in, and how can research solve all these problems, or part, or help, right, to solve part of the problems here?
Well, I think all these problems must be sorted out step by step. And I'm happy you talked about the long-term nature of the business. I was in 2005 testing the first floating wind turbines at the ocean basin of Sintef, and today you're discussing it as a big business. This is exciting. And I think every industry is going through these changes. So in the future, I think what's important, as Bo was mentioning, is the recyclability of blades, for example, and I think organic materials, biomanufacturing will become important. But I think every industry is trying to move away and become carbon free. We're working on projects with the steel industry to make carbon-free steel, for example, removing the carbon, I don't know the word in English actually for the carbon contents, but putting in hydrogen in the steel industry, in the aluminum industry, etc. So it all hangs together, as we say in Norway. But I think the value chain and the interdisciplinarity is critical. Floating turbines will obviously also have the benefit of being able to be assembled closer to shore. The entire value chain needs to work together. And I just also wanted to comment on Rasmus's wicked problems with regards to these hybrid projects availing themselves of different markets. And there's a lot of politics involved in that. Who's gonna make the money? But there's also some science involved in that. And our experience, for example, on security of supply and redundancy in the grid, putting together common European collaboration projects in research is one way of paving the way for an intelligent discussion where at the end there's some horse trading in terms of politics, but I think you can do some fundamental, you can put a lot of mileage into these problems by challenging researchers to work together. That often helps.
Thank you very much, Alexandra. I think looking back at some of your statements there, both you, Rasmus, and Elisabeth kind of alluded to it, that it's needed. But I want to touch a bit on the grid and the importance of having a proper grid designed to make sure that we deliver this sustainable wind power to the consumers. I mean, Elisabeth, you are offering the electrification solutions to the consumers for the transport sector, for the heating sector and so forth, while you, Rasmus, with Ørsted are focusing in generating that electricity, that's sustainable energy that we all need. But in between, is it an infrastructure that we all depend on? And we need to make sure that also has its proper development cycles to ensure that it supports our ambitions here. Can we, maybe Rasmus, start with you, and then Elisabeth could comment on how important this is to get it aligned.
Certainly, I can start very quickly. It is back to some of the points that has been made during today. On Elisabeth mentioned at some point in the beginning that these are large-scale projects that are expensive and that they take time, and you need to look at the energy system as a whole. Right, so it's very in us that we believe that we are, while we have been on a very significant transformation in the industry, but also in us in the last 10 years, bringing down cost of 70% for offshore wind. What we have in front of us, especially here in Europe, is a transformation that is, I would say, even more daunting than what we have been through, exactly because these projects needs to be seen as one. So I think that the one point that I will make, Adrian, is to basically repeat what I said before about the timeline for these projects, and basically, the anticipatory investment thinking that you have to make around this, and whether that is in the energy islands in Denmark, whether that is in the upcoming energy island in Belgium, whether that is in Norway, all across Europe. This is the way that one would have to think. So I think this is my main point about anticipatory investment and partnership thinking across the entire industry. Otherwise, we will not be successful with this task.
Thank you, Rasmus. Elisabeth, anything else to add?
Yes, no, thank you. And picking up on what Rasmus has said, we've talked about the real estate in the sense around offshore wind with spatial planning. What has been missing in some of the dialogue that I've heard is the real estate planning also for the grids. A big bulk substation takes a lot of space. So we need to make sure that in addition to the anticipatory planning and rate making design, as Rasmus was talking about, we also need the coordination in terms of policymakers and government leaders down at the local level, actually, to make sure that areas that we're protecting and also enabling the reutilization of infrastructure. So for example, when a coal plant is shut down, actually that big grid interconnection site and that bulk substation is really, really valuable. That's a really valuable asset. How do you make sure that you're reusing that, and how do we're thinking then from a hub standpoint and making sure that we're taking the best reuse of that existing infrastructure. So there's a lot of brownfield real estate when you talk about the grids as well. And that's something that I haven't heard included in the discussion. So I wanted to add that in, because that is something that's really, really important. How do we make sure that it's sort of like we're closing down the coal plant from an emissions and polluting perspective, but we're recognizing, wow, there's really great critical infrastructure assets there that can be redeployed for green purposes. And that also, if you don't have to build a whole new bulk substation, you're actually, again, saving society a lot of money. So thinking, again, very, very practically about reuse as part of this, and then also thinking through in terms of the grids at the nodal level. This connects into market design and regulatory reform for market design. How do we make sure that we have an ability for participants to make money through for greater resiliency, flexibility services, ancillary services, voltage, frequency, these types of things? Because as I mentioned before, distributed energy assets, whether they be electric vehicles, charging points, home batteries mapped with storage like our Sonnen, all these different types of solutions, whether they're individual consumer products on the home or they're larger scale, when you actually aggregate these, they can become a virtual power plant, and you can actually provide local reliability and stability at the grid level that helps at the distribution level. So when you think about it as a systems perspective and you align market regulation, where then market participants can actually enable that economic vitality, you're actually helping to green your grid and stabilize the grid at the same time. So again, thinking through that systems perspective, it also is something really important is that the customers want to and need to participate. As we're talking about scope 3 emissions are always the biggest point of emissions for all of us. So how do we make sure that we're creating a virtuous and affordable way for everyone to participate so that we're not leaving anyone behind? And that's what I love about a lot of these distributed energy resources, like when you pair solar with a battery or things like that, you actually minimize the monthly bill for a consumer. They have better home predictability. And so actually you're actually helping society as well at the consumer level, so they're able to have more affordability too. So as we bring everyone along on the journey, I think if we think about it in that way, we can actually align the policy, align the technology, align the customer benefit, and then you get that sort of virtuous ecosystem that we're all looking for.
Great, thank you, Elizabeth. One more question coming in here, and this is maybe for you, Bo, and also Rasmus, if you can comment on it. How do we make sure that wind in Europe will be made in Europe?
Yeah, just touching a little bit on what Elizabeth and also Rasmus said. I think we need all these new systems and system integration and supporting the grid, and the technology has to be developed by somebody, right? And the industry wants to develop that technology to be deployed. And I think being the first mover in that, seeing these things come online for the first time, will make us a competitive advantage in Europe, right? We develop the first solutions, and the solutions we can prototype and demonstrate in Europe. So I think the demonstration projects is essential for developing these technologies so we can expand and develop them and develop the supply chain and bring the supply chain on a global scale. But starting where we are and starting locally, we can make sure that Europe has a forefront and a competitive edge when we want to move. Then short on the floating, I really think that we need some standardization within floating foundations, right? The beauty with that is that whenever it's floating, right, it could be more or less the same. So some kind of standardization of technologies and design, I think, will be needed in order to create the scale that is also needed to have it coming down in cost. I think the possibilities are there, but I think standardization of these things are essential, bringing that technology forward. But being the first, having the competitive edge, I think is essential for Europe.
Yes,
and if I should, if I should supplement a little bit on whether I believe that offshore wind in Europe will be produced in Europe, I am not concerned in any way that will be the case. So when we look at new markets, and that is the same for our supply chain, we usually look at three things. We look at ambitious political targets. We look at the right, appropriate regulatory framework, and then we look at a project pipeline. If you have those three things, then you will also get offshore wind development, and you will also get the supply chain to invest. So I'm not in any way concerned. And just to give you one example, take Poland. Ørsted has recently moved in big time in Poland together with our partner PGE with a 2.5 gigawatt, two projects. A significant part of our investment rationale for that has also been that already today there is a very mature supply chain in Poland. They have just produced offshore wind components for the rest of Europe, but never for Poland and for the Baltic Sea. So for us, that's a significant part of our thinking when we are moving into the Baltic Sea region, that you actually have companies already like Poland with a very mature supply chain. So I'm not in any way concerned that we would also be able to do that also when it comes to floating, also when it comes to hybrid solutions, provided that we have the three things that I mentioned in the beginning.
All right, look, questions are still popping in here, so we only have a few minutes, but let me take another one here, and maybe, again, seems like you, Elisabeth, and Rasmus are kind of a team for our audience here, but they would like to see how the wind park owner harness the potential of big data and artificial intelligence, right? As techniques to reduce cost of operation maintenance, to reduce safety, also, how do we share data across stakeholders in the industry? How do we make the most use out of it? And if Alexandra can also chip in something from the technology there, then we will create as a closing question here.
Well, at least I could say that I
Yes.
could start out by saying
Please,
that when the European Commission has set their strategy for data-driven innovation, and the energy area is one area where they're trying to put together a data space for data sharing. And I think it's so important for industrial competitiveness that I think it's essential to take a leadership on safe sharing of data. So I think from a research side, in order to create a strong European industry, this is something that I really hope the operators will put their arms around and embrace, I guess is the correct word.
And then maybe one quick comment from my side on data, and that is just appreciating that this is incredibly important. And it's also here a bit of a daunting task. In Ørsted, we have data from 30 years of offshore wind farms. So at some point, one could argue that we are, it has felt sometimes like we are data rich but information poor, because we have not been able to fully sort of translate that massive amount of data into something that we could really use for our operations. So 3 years ago, we really started to make a complete step change in the way that we approach digitalization, also together with the OEM. And it is obviously, to your point, quite sensitive, because it is a competitive differentiator, but it is something that we spent a lot of time on to optimize the operations of our wind farms, but also to innovate on new solutions that we are using for upcoming solutions and tenders.
Yes, and building on that, it is sensitive because of the competitive differentiation, but building on what you said, Alexandra, there's really good standards and ways where you can have reciprocal data sharing that's anonymized. When you think about the systems planning we've been talking about with the grids. And so thinking about how we're solving congestion, how you're solving planning at a systems level, I think there's some really good models around the world where you've been able to strike that right balance, where individual companies and developers are able to maintain their intellectual property and their secret sauce, as it were, to compete. But then at the same time, also, you have really good mechanisms for that data anonymized that supports systems access and planning, which is really important. I also want to note as well that Shell and in our business, we have a really, really proud AI team. We're really, really leaning in, and we've been taking, it's actually an offshore engineering expertise that has been in the company for decades and decades and decades. And what it does is something that is actually an important topic for another conversation, which is safety. So already my business and Shell, our renewables business, we're a leading safety business within the offshore wind industry as a whole. And we've been really actively working hard to really lift the standards and also lift safety standards across the electricity sector as well. And so that's something that, because of the heritage of our company as a whole, as a safety leader, we recognize that energy is so, so important to be safe. And this is where AI and machine learning, predictive maintenance, all of these advanced internet and software technologies become really, really practical to not only ensure optimization and improved planning and cost effectiveness, but most importantly, really, really safe operations, which again is really important for society. So great question, and worth a whole nother, I think, AI and digital technology.
A dedicated event on it, yes, indeed, indeed. And we are also running out of time here. So let me just wrap it up with some closing remarks that I noted down here on my desk while all of you were speaking. And thanks a lot for taking again the time to be with us today. Such an important event for ETIPWind to release this report, to show to the world how can it be done, right? I noted down here that we are all committed to get fit for 55 and ready for 2050. No matter whether we are industry, we are research or policymakers, we all want to implement this and get it done, right? Innovation is still needed. It needs to help us scaling up, being the offshore grid infrastructure, being the floating part of it, or being the necessary grid infrastructure to connect to our consumers and have all the solutions there for electrification of our loads. But at the same time, we need to keep in mind that we need to be cost effective, we need to be efficient and get it done properly, such that it's not a big cost for us as citizens of that. And we need to look at it to be more sustainable than already wind is, right? And look and use materials to build up our assets, look at circularity and minimize the use of materials in our products, in our infrastructure to be deployed. In addition to innovation, also collaborations are needed. I mean, we are in wind as a family all together in the same boat, and we need to get it there. But we are starting intersecting more and more with other sectors, the power system sector, the energy storage sector, the power to X sectors, and we need to start collaborating and understand how we can make it more efficient, right, by collaboration and get proper concept for us to be fit for 55 and ready for 2050. So let's go out there and do it. Thanks again one more time, and looking forward to the next section where we will go in depth into a technology discussion. Thank you all.
Thank you. Bye-bye.